Hello everyone, welcome back to Fun with Science. And today we will learn how to obtain equation of motion. Let us consider an object starting from position A whose initial velocity is OA, moves with respect of time and reaches at the position B. Let us draw a perpendicular line BC at the x-axis. Draw a perpendicular line AD to the y-axis, which shows the time. Here, AD is equals to OC equals to time. And draw a perpendicular line BE at y-axis. This is the final velocity. Here, BC is equals to OE equals to final velocity, and OA is equals to BC equals to initial velocity. So, let us start learning how to obtain first equation of motion. We will use the same graph here also. Here, from the figure, we have BC is equals to BD plus DC, or else BD plus OA. Now we will substitute values. Here BC is equals to final velocity and OA is equals to initial velocity. By substituting these values, we will get we will mark it as equation number 1. Since the object is changing its velocity, it will have some acceleration. Acceleration is the change in velocity divided by time taken. Here, change in velocity is BD and the time taken is OC. Here Vd is equals to V minus U from the first equation. And OC is equals to time. Therefore, acceleration is equals to V minus U by T. Here, by graphical method, we have proved the first equation of motion. Now, we will prove the second equation of motion. Here, to prove this, we have to use displacement. The displacement is equals to the area of rectangle AOCD plus the area of triangle ABD. So the formula for area of rectangle is length into breadth. Here length is OA and breadth is OC. Half base into height. Your base is AD and height is BD. Here OA is initial velocity, OC is time taken, and BD is change in velocity. By substituting these values, we will get we know that A is equals to V minus U by T. We have proved that earlier only. When we move this T to LHS, we will gain AT is equals to V minus U. We can replace this V minus U to AT. Let us name as equation number 2. We will apply this equation number 2 in this formula. This S is displacement. Finally, we will get we have also proved the second equation of motion. Now, let us prove the third equation of motion. Here also, we will use the same graph. Here, displacement is equals to the area of trapezium OABC. We know the formula of area of trapezium is equals to half into the sum of opposite side. Into height. Here also, by substituting OA is equals to U, BC is equals to V, and OC is equals to T, we get into T by 2. When we move this T to LHS and move this A to RHS, we will get V minus U by A. We will use this equation here. After using here, we will get after solving this equation, it will result as 2as is equals to v square minus u square.